Have you ever wondered if a machine can really think like you do? You see a cat and instantly know it's a cat. No checklist needed. But now, we're teaching machines to do that same kind of magic. It's not science fiction. It's happening right now. This isn't about robots with feelings. It's about building systems that learn from data. Just like you learn to tell cats from dogs by seeing lots of them, machines learn by looking at millions of digital pictures. The big question, how do we get a machine to learn without programming every rule? Instead of endless lists, we show the machine tons of examples and let it figure out the rules itself. This is the heart of machine learning, inspired by our own brains. Get ready. We're about to explore artificial neural networks, the technology behind your favorite apps and self-driving cars. Let's dive in. So, what is an artificial neural network? Think of it as a digital brain, inspired by the billions of neurons in your own. Instead of cells, it's made of code and maths, designed to spot patterns in huge amounts of data. For example, it can learn to recognize handwritten numbers just by seeing thousands of examples. No rules needed. Imagine it as a team of tiny decision makers, each checking a piece of information and passing their vote along. The network is built in layers: input, hidden, and output. The input layer takes in data. Hidden layers analyze patterns, and the output layer gives the answer, like cat or dog. The more layers, the more complex the patterns it can learn. This layered structure is why we call it deep learning. Neural networks are powerful pattern detectors, learning from experience just like we do. That's the magic behind the scenes. Let's zoom in. The basic building block of a neural network is the artificial neuron, or node. Think of it as a tiny calculator. It gets inputs, multiplies each by a weight, how important it is, adds them up, and decides whether to fire based on a threshold. If the sum is high enough, it sends a strong signal to the next layer. If not, it stays quiet. These weights are what the network learns and adjusts. One neuron alone can't recognize a cat, but link thousands together and you get powerful intelligence. The magic comes from millions of simple interactions between these tiny thinkers. Simple rules, complex behavior. That's how neural networks work at the smallest scale. Let's see how they learn. So, how does a neural network get smart? It's all about training, a giant guessing game. At first, the network's weights are random, so its guesses are wild. We show it labeled examples, like thousands of cat photos, and it makes a prediction. We compare its guess to the correct answer and measure the error, called the loss. The goal: adjust the weights to make the loss as small as possible. This cycle: guess, check, adjust, repeats over and over with tons of data. Each time the network tweaks its weights just a bit, slowly getting better. Over thousands of examples, it learns which patterns matter. The right weights get stronger, the wrong ones get weaker. That's how a smart model emerges from simple trial and error. After measuring the loss, how does the network know which weights to change? Enter backpropagation. Think of it as passing the blame backward. Each neuron learns how much it contributed to the mistake. If a connection led to a wrong answer, its weight is lowered. If it helped, its weight is increased. It's like a performance review for every connection. Backpropagation gives precise feedback, so the network doesn't have to guess randomly. This process, forward guess, backward correction, repeats millions of times, Slowly, the network's guesses become accurate predictions. That's how neural networks learn from their mistakes. It's the secret sauce behind modern AI. How does the network know how much to change each way? That's where gradient descent comes in. Imagine you're on a foggy hill, trying to find the lowest point by feeling which way is downhill. The hill is the loss function. The bottom is minimal error. Gradient descent calculates the steepest direction to reduce error and tells the network to take a small step that way. The size of each step, the learning rate matters. Too big, you overshoot. Too small, it takes forever. With each step, the network gets closer to the lowest error. After many steps, the weights are tuned for the best performance. That's how neural networks optimize themselves. Neural networks are everywhere in your daily life. Unlock your phone with your face. That's a neural network. Use Google Translate. Neural networks power instant language translation. Streaming services recommend shows based on your viewing habits again. Neural networks at work. Even self-driving cars use them to recognize objects and make decisions in real time. These systems find patterns in everything from entertainment to transportation. Neural networks are quietly shaping the world around you. You use them every day, often, without even knowing it. Think building a neural network is only for experts. Not anymore. With free tools like TensorFlow and PyTorch, anyone can experiment with AI. You don't need a PhD, just a computer, internet, and curiosity. Tons of tutorials and no-code platforms like Google's Teachable Machine make it easy to get started. You can train a model to recognize images or sounds right in your browser. The best way to learn is to try it yourself. Build, test, and tweak. AI is now an open playground for everyone. So take the first step and see what you can create. The journey starts with a single neuron. We've gone from asking if machines can think to understanding how they learn. Neural networks aren't magic. They are clever systems inspired by our brains. They learn by trial and error, finding patterns in messy real-world data. This technology is changing everything from healthcare to entertainment. It's not just for scientists. Anyone can learn the basics and join in. Understanding machine learning gives you a new lens on the world. Stay curious. Keep asking questions and don't fear the jargon. We're teaching machines to see the world and learning more about ourselves in the process. The future is what you make it. Let's get to work.